Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video, another video in our series of videos dealing with the binomial distribution and calculating binomial probabilities, is going to continue with an example that we have explored in previous videos. Okay, and it's this example here where we have a bank estimates that there is a 30% probability, that there's a 30% probability that each loan will not be repaid. Okay, and that's important. The context of this question, it's all about loans not being repaid, and also that in a certain week the bank gives out 10 loans. So here's another important piece of information for us. Okay, that 10 loans are given out. We know that in that the probability that a loan will not be repaid is 30%. Okay, that's the context. Not repaid, will not be repaid. Okay, and this question wants to also to estimate what is the probability that up to 8 loans will not be repaid. Okay, let's think about it. There's a number of things that could happen for us here. Okay, we could have a situation where we have that, let's say, out of the 10 loans, that 0 of them are not repaid. In other words, that means that they're all repaid. The other possibility is that we could have 1 of them out of the 10 not repaid. We could have a situation where there's 2 not repaid, 3 not repaid, 4 not repaid, 5 of them are not repaid, 6 of them are not repaid, 7 of them are not repaid, 8 of them are not repaid. Out of the 10 loans, that 9 of them are not repaid, and then finally, out of the 10 loans, that 10 of them are not repaid. Okay, these are all the things that are going to happen, and any combinations of them can happen as well, if that makes sense. Yeah. Okay, so what we're interested in is what's the probability that up to 8 loans will not be repaid. Well, let's think about it. Zero would be included in that, because 0 is up to 8 loans are not repaid. 1 would be included, 2, 3, 4, 5, 6, 7. Any one of these possibilities, and up to 8, okay, would be possibilities that we probably don't want to see happening. Well, actually, we would want to see 9 or 10 happening, yeah. But in this question here, what's the probability that up to 8 loans will not be repaid? Well, what could happen? 4 of them could not be repaid. 5 of them might not be repaid, and so on. So actually, any one of these things could happen. That could happen, or that, 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 or that. So once again, we have the or, which is the addition rule. Okay, so actually what we need to do is we need to calculate all these individual probabilities, okay, which is a lot of work to do with respect to the binomial distribution. Is there a shortcut? Well, let's write them down in probability terms. Okay, so we have the first situation, okay, that I had there. Okay, let me just fold this over here so that we can actually have a look at this in a little bit more detail. Okay, oops, just fold it over that fold neatly. Okay, there we go, brilliant. Okay, so let me just fold that over there. Okay, so the first situation is 0. Okay, that's x takes on the value 0. Okay, so let's have a look at that. So we have what could happen is the probability that x takes on the value 0, which means that none of the loans are not repaid. In other words, they're all repaid. The other thing is that x is equal to 1. That one of the loans is not repaid. Then we have the probability that x is equal to 2. That happens out of 10 of them, that 2 of them are repaid. And then we have the probability that x is equal to 3. That 3 of them are repaid. The probability that x is equal to 4. 4 of them are repaid. The probability that x is equal to 5. 5 are repaid. The probability that x is equal to 6 are repaid. The probability that x is equal to 7 are repaid. The probability that x is equal to 8 are repaid. The probability that x is equal to 9 of the loans are repaid. The probability that x is equal to 10 of the loans are repaid. Okay, but the important thing that we know is that each one of these are mutually exclusive, and they're exhaustive. They exhaust all the possibilities. So what we know is that the sum of all these probabilities, okay, that when we sum them up, okay, that what we should get is we should get them all to sum up to be equal to 1. Okay, now what we're interested in, okay, is we're interested in calculating this summation here, okay, from 0 all the way through to 8. Okay, so actually what you can actually see now from let's say an equation perspective is that actually this red piece, which is a summation from 0 probabilities through to 8, would actually be equal to 1 minus these 2 probabilities. So actually what we have